Hello guys, in this video I'm going to show you how to solve k closing points to origin. So given an array of points in 2D plane, find k closest points to the origins. So by origins means the point 0 and 0 x coordinate and y coordinate is both 0. So we're given a list of points, right? There are 3 points in this example, and k is 2. So we have to find k closest point to the origins, right? 2 closest points to the origins out of 3 points. So how do we get these 2 points, right? So here is the formula we're going to use to calculate the distance between 2 points, and for our case it's the distance between each point out of the input to the origins, right? So here, as you can see, x coordinate, here is the formula. So for example, to calculate the distance between let's say 1 3 and 0 0, it will be square root of what? Of 1 square minus 1 square plus 0 square. Wait a minute. Oh no. 1 square. No. 1. Sorry. 1 minus 0. Okay. The square plus 3 minus 0 square. Okay. So this will equal to square root of 1 square is 1 plus 3 square is 9. So it's 10 in total. So square root of 10. Right. So we can calculate the distance of every point to the origins, right? So our problem comes down to find the smallest, right? Smallest distance of each point, k smallest distance, right? So let's say this guy we have three distance in total, right? 3 points, so 3 distances. Square root of 10, the next one is square root of 3 square is 9. 9 plus 16 is 25. Okay. Here 4 plus 1 is 5. Okay. So our goal is to just find the two smallest distance, right? And it's pretty much the same as k smallest number. Problem that we've already solved in the previous videos in this category. So let's try to solve it, right? The only difference is we need to calculate the square root, right? Sorry, the distance between each point with the origins. So we wouldn't have a utility functions that help us to do this. Let's call it distance. Distance to origin. Okay. Maybe we have functions that takes in the point itself. The point will be in form of an array where first element is x coordinate and second is y coordinate. Okay, we have the point is let's implement it later. So if I close it, points origins, so the approach is same as k smallest problem, right? So for k smallest numbers, want to use a max heap, right? Because at any point of time we want to get access to the largest number in the heap. We try to maintain the heap. Now having at max k numbers. In our case, is k distances. So at any point in time, we have access to the largest distance. So we iterate for every distance, right? So if a distance, the current distance is smaller than the largest currently in the heap, then we'll make a swap between these two, and at the end of the loop, we're going to have a k smallest point, k smallest distance in the heap, right? So we're using max heap, new heap. Let's say heap is not available in JavaScript. We want to use a third-party library. If heap is a class, so we initiate an instance heap, passing in. So it's empty initially, right? And the third arguments will determine whether it is a min heap or max heap, right? Max heap takes in two arguments A and B, and we want to use this distance functions to gonna store point in our heat, right? But now we have to provide a way for the max heat to determine to determine how wanna calculate the distance between each point to the origins, so that we can build our heat in a way that we always have access to the point with largest distance to the origins. So A and B here is 2 points, right? So I'm gonna call distance to origins of point A minus distance to origins of point B. Okay. So the first, I want to use 2 loops here. The first loop, push K points to the max heat, right? And the second loop is going to be trying to selectively swap point with peak of heat. So for the first loop, push K points to the max heat. Okay, we use a for loop that I equal to 0, I less than K. So I will run from 0 to K minus 1. I plus the total of K loops here. So after K loop we have K points in the max heat. So max heat at what? At the points at current index, which is I. Okay. So for the second loop, when I run from that's I equal to, here we run to K minus 1, right? So the next loop will be from K less than point length. Okay. Plus 1. Okay. So for each iteration of the second loop, we want to only push in the make it swap only if the current point is a better choice than the point with largest distance in the heat, right? So we want the heat contains smallest distance. So if the current point distance current point to origins, we use our utility functions passing the current points, which is point I. If this distance is less than the distance of the largest distance in the heat, which is max heat, distance to origins of max heat. Okay, a peak. Okay, if this is better than I just want to swap here, want to pop out from the box here, and then push the current point to max heap. Okay, points at I. Okay, so after all, the return max heap content. Okay, the last thing to do is to implement this functions, right? So distance origins will be return square root from the map. Okay, sqrt on square root of what we have here is x coordinate of the point minus x coordinate of origin is always 0, so same as points x coordinate times x coordinate. The same here. No s here. This will plus y coordinates of point times itself. Okay. Let's run a test. Just 13 and 3. Okay, that works. Okay, so that's it for this video. So thanks for watching. See you in the next video.